In this video, we will do some College Board multiple choice questions pertaining to the tangent function. This is AP Pre-Calculus, topic 3.8. If you appreciate the content, please give it a like. Number 1. The function p is given by p of theta is equal to 3 times the tangent of pi over 2 times theta plus 1 minus 4. What is the period of p? We have learned that the tangent function has a period of pi divided by whatever the b value is. The b value is this number right here inside of the parentheses. So in this case, the period is going to be pi divided by pi over 2. When you divide by a fraction, you multiply by the reciprocal. So we get p is equal to pi times 2 over pi. The pi's cancel out, and you are left with a period of 2. So the answer is C. Number 2. The function g is given by g of theta equals the tangent of 2 pi theta. Which of the following statements about the graph of g in the xy plane is true? Each answer choice gives an equation representing the infinitely many vertical asymptotes of tangent 2 pi theta. Tangent is sine over cosine, so g of theta can be written as the sine of 2 pi theta over the cosine of 2 pi theta. G of x will have a vertical asymptote wherever it is undefined, in other words, wherever the denominator is equal to 0. So we can find the vertical asymptotes by setting cosine of 2 pi theta equal to 0 and solving. First, we solve for the inside expression, so we need to find the possible values of 2 pi theta. Ask yourself the cosine of what is equal to 0. Cosine is the x value on the unit circle, and over here on the right, the x value is 1. This is a unit circle, so the radius is 1, so we are 1 to the right. But right here at the top, the x value is 0 because we are right on the y-axis. To the left, the x value is negative 1, and then down here at the bottom, the x value is back to 0. So the question was, where is cosine equal to 0? Well, the x values, and thus the cosine, are equal to 0 right here at the top, which is pi over 2 radians. And then right here at the bottom, so if I keep going around, this is 3 pi, this is 3 pi over 2 radians. So we can convert this to infinitely many solutions by adding multiples of 2 pi, since 2 pi is the period of cosine. So this will become 2 pi theta is equal to pi over 2 plus 2 pi k, or 3 pi over 2 plus 2 pi k, where k is any integer. However, this turns out to be a special case where we don't actually need to write two separate equations to represent the infinitely many solutions to this equation. That's because the two solutions that we found on the interval from 0 to 2 pi just happen to be separated by exactly pi radians. Because of that, we can start with the first solution right here at the top at pi over 2 and add pi to get to the next solution. Then, if we add pi again, it takes us back to the first position and another solution. And in fact, if we keep adding pi, it takes us from one solution to the next solution to the next solution. So instead of having two separate equations and adding multiples of 2 pi, we can have one equation and simply add multiples of pi. So we will add pi k, where k is any integer. We just have to solve algebraically for theta. So let's divide both sides of this equation by 2 pi. So I need to divide by 2 pi here, and here, and also here. You can divide pi over 2 by 2 pi by placing the 2 pi into the denominator and multiplying. So we have pi over 2 times 2 pi. The pi's will cancel out, and in the denominator we still have 2 times 2. So the first term ends up being 1/4. In the second term, the pi's cancel out, and we just have k over 2. K over 2 is the same thing as 1/2 k. So this could be written as 1/4 plus 1/2 k. So that matches answer choice B. So the answer is B. Number 3 is calculator active, so we will use our graphing calculator if needed. The graph of the function g is given in the xy plane. If g is the result of multiplicative and additive transformations of the graph of y equals tangent x, what is the period of g? One way to find the period of a tangent function is to find the distance between consecutive vertical asymptotes. Another way to find the period of a tangent function is to find the distance between consecutive points of inflection. In this particular case, the second way will be the easiest because we have a point of inflection right at the origin, and the next point of inflection is at pi over 4. So we can easily see that the distance between points of inflection is pi over 4, so the period is pi over 4, and the answer is B. Number 4. In the xy plane, an angle theta in standard position has a measure of theta equals pi over 3. Which of the following is true? I see that all of the answers are about the slope of the terminal ray. We have learned that the tangent of an angle is the slope of the terminal ray. So the slope will be given by the tangent of pi over 3. If you have not yet memorized these 9 trig values, pause the video and memorize the chart right now. We have memorized that the tangent of pi over 3 is radical 3. So the answer is D. Number 5. The graph of the function h is given in the xy plane. If h of x is equal to a times the tangent of bx plus 10, where a and b are constants, which of the following is true? We have learned that the parent function, tangent x, is always increasing. So, if the function h is always increasing, that means there has not been a reflection over the x-axis. In other words, the a value in front must be greater than 0. If a was negative, if a was less than 0, this would be upside down and we would be having a decreasing function. So again, since the function h is increasing, just like the parent function, the a value must be a positive number. So we have narrowed it down to either a or b. Now we need to decide if the value of b is greater than 1 or between 0 and 1. We have learned that the period of the tangent function is pi divided by the b value. Or if you solve this for b by switching the p and the b, we know that the b value is equal to pi divided by the period for the tangent function. The period of a tangent function is the distance between consecutive points of inflection. Since this point of inflection is at an input value of 0, and the next point of inflection is at pi over 2, the distance between them is pi over 2. So the period is pi over 2. That means that the b value will be pi divided by pi over 2. When you divide by a fraction, you multiply by the reciprocal. So b will equal pi times 2 over pi. the pi's will cancel out, and you get b is equal to 2. This is clearly greater than 1. That means the answer is A. Number 6. The function f is given by f of x equals a times the tangent of bx, where a and b are constants. Which of the following statements is true about the period of f? In problem 5, we discussed the fact that the period of the tangent function is completely determined by pi divided by the b value. So only the b value affects the period, not the a value. The a value is a vertical dilation by a factor of a. Stretching the tangent function vertically has no impact on the period. So the answer is C. Only the b value has an impact on the period of f. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.